Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. And today's topic is about 3 unexpected ways you might be doing many-to-many joins in PROC SQL. Before going into the topics, I would like to discuss one particular thing. That is, I have made 3 different videos on this topic, and what I'm doing in this video is I have brought them all together. And this is very important because many times we do joins, but we do not understand these joins completely, and we might be doing many joins, because of which we might be getting large data sets and also we might have wrong results. These are the 3 topics or 3 issues which cause many joins, and this raised mainly because of either problems with missing value in joining column or columns, or these problems arise when you are doing joining and doing aggregation at the same time, or we are doing joins based on index function. Now let us discuss the first topic. What are the problems with missing values in joining column or columns in PROC SQL? Let me quickly explain how I am going to discuss this topic. First, I will introduce what happens when we have missing values in joining column or columns in PROC SQL. Then I will go in details of what problem we are going to see with this one, and then a solution. Now to understand this, let us look into some sample data sets in here. Here I have 2 data sets. The first one is known as data 1 and the second one is known as data 2. And if you see in here, we have 2 variables each in both the data sets. In the first data set, I have variable ID and name as variables, whereas in the case of data 2, I have ID and age as variables. Now, if I want to join this data set 1 and 2 based of ID variable, what would happen? If you see in here, there are 3 observations in here and there are 3 observations in here. I'm doing a join based of ID variable in both the data sets by saying something like this: select a dot star age from 1a. That is, I'm aliasing dataset 1 as a, inner join 2, I'm aliasing this as b, and I'm joining based of ID variable, and I'm getting all the variables from the dataset 1. But the most important point in here is when we join like this, what happens is, if you see ID1 is equal to ID1 and you see that in the result in here, and ID2 is equivalent to 2, so you see this observation in here in our result. And a very interesting point in here is missing value also we see in here, and what PROC SQL does in here is matches this missing value with this missing value and gives a result like this. This is quite unusual. This happens only in PROC SQL, and many of other SQL implementations in databases and others, they generally ignore missing value. This is very important. Now that we have understood what happens if we have a missing value in the joining column in PROC SQL, now let us see what are the problems with this one. Now let us look into a different data sets wherein again we have same variables ID and name, and this data set is 1_1 and data set 2 is now known as 2_2. The difference between the earlier data sets and these data sets is we have multiple missing values in these data sets. Here I have 2 missing values in dataset 1_1 and 2 missing values in dataset 2_2. And in here I am doing the same join, only thing is the dataset names are different and everything else is same. Now if you look into the results, you can see that we have 4 missing values and we have 4 observations related to missing values. Now let us try to understand why this happens. We have 2 missing values here and we have 2 missing values here. Each of them are equivalent to each other. If we have many values which are same in one table compared to other table, so the problem here is when we have many missing values here, many missing values here, we are going to get many joins and we are going to get a result like this. This kind of result what we have often makes the data set large, and also the result becomes very confusing. This missing John is equivalent to this missing 40, and this missing John is equal to missing 50. That is what we have seen in here. The same is the case with missing Megan. So we have many rows and we even cannot understand what these rows mean. So we have two problems here. The first one is many to many join issue. One major problem with many to many joins is if we have lot of missing values in data set 1 and data set 2. Say for example we have 10,000 missing values in here and 10,000 missing values in here, and the resultant data set becomes very large, and also we cannot understand the results. So how do we avoid this kind of joins? Is to avoid this, what we can do is we can add an AND condition for this code, and something like this we can do, wherein we are saying and a.id is not null or b.id is not null. What we are saying is whenever we are joining on this id variable, we do not want to have anything joined when either this id variable has a missing value or this id has a missing value. So when we do this, our results become clean, and now we are ignoring null or missing values. So we get our result something like this. So this solves our problem. Now let us move on to the next topic, which is problems with joining and doing aggregation in the same query in PROC SQL. Now, before going into this topic, let us quickly look into some sample data and try to understand this topic much better. Here I have two sample data sets. The first data set is known as data purchase, and then it has three variables: product, purchase underscore amount, purchase underscore date. And the second data also has product as a variable, and it has sold amount and sold date as another two variables. Now let us have a closer look at our data in both the data sets. In here I have just have one product, candy, and in the sold also I have only one product, candy. And what I want to really do is I want to see what is the total purchase underscore amount for candy in this data set, and also total sold underscore amount in this data set, and I want all of this in one result or in one data set. To do that, what we can do is we can join this purchase table and sold table as I'm showing you in here, wherein I'm doing an inner join between purchase and sold data sets on the basis of product. And also we are doing an aggregation for purchase underscore amount and sold underscore amount by product. And this gives result as shown you in here. But if you see the result, there is a problem. Our total purchase underscore amount, which we got by doing sum of purchase underscore amount, is 45. Our total sold underscore amount, which we got by doing sum of sold underscore amount, is 63. But if you manually see, our total purchase underscore amount should be 15 and our total sold underscore amount should be 21. This is 3 times more. Now let us try to understand why this is happening. Before going into the details, first thing I wanted to tell is whenever we write a query in a plain English and we submit the query to a SQL optimizer, and what SQL optimizer does is it behind the scene builds the way the query should be executed, and that causes the difference. And now let us see how SQL optimizer executes this query. So to understand this, let's move on to the next slide. Whenever we have a query, as I said, the SQL optimizer decides what to do. In here, the query what we have submitted does not run in one single step, but it runs in two different steps by SQL optimizer, which often we don't see. In here, what happens first is an inner join happens. That is, this data set and this data set are joined on the base of product, and this is the result we get, because here we have three candies and here we have three candies. When we join, as there is one candy in here which matches with three, second one also matches with the three candies in here, third one also matches with the three of them. So we have a many to many join and we get 9 observations. And in here our purchase underscore amount is there for 9 times, sold underscore amount is there at 9 times, and then SQL optimizer does our aggregation, wherein it does sum of purchase underscore amount and then sum of sold underscore amount. As 5 is there 9 times, this becomes 45, and sold underscore amount is there 9 times, 7 into 9, 63. So that is why we see the result in here. Now, how are we going to solve this? It is pretty simple and straightforward. That is, first we need to sum this candy in here in purchase, wherein we get 15 as our total, and then we need to sum the sold also in here and get 21, and then do the join. Now let us look that more clearly in the next slide. In the next slide, if you see, in the first step I am doing aggregation on purchase data set, wherein I am saying some purchase underscore amount, and then I am doing group by product. So as I have three candies with $5 each, and then when I am doing by product, my total for candy will be 15. So I have total underscore purchase underscore amount as 15, and then I am doing again separately the same thing for sold data set, and I have candy value of 21. Now I have done aggregation separately and I have got my totals, and total purchase underscore by product, total sold underscore by product are my two data sets which are already aggregated. Now I can join them and I can get the result back in here. Now what we have really done is we have changed the execution order by ourselves, and we did not allow SQL optimizer to do this. This is especially important when we have many observations with the same value in the joining column on both the data set. This way we have avoided many to many joins for our second problem. Now let us look into the third and last topic, which is unexpected results when doing joins based on index function or the like operator. Here, these are little bit different joins than regularly what we see. To understand this, again let's look into sample data sets, and in here I have sample data set 1 underscore 5 underscore full, wherein I have two variables var1 and var2, and I have another data set wherein the dataset name is 2 underscore 5 underscore partial, and in here I have call1 and call2 as my variables. Now if you look in here, we don't have anything same on both the datasets to do a join, but many a times we do joins on this basis also, that we have one complete full string here, that is var1, and we are looking for the partial string in here, and we are doing a join. And this join can be simply done something like this, wherein I'm saying 1 underscore 5 underscore full as full in a join 2 underscore 5 underscore partial, and here the on condition I am giving here is little different. What I'm saying is index var1 comma call1 greater than 0. So what this does is, whenever this call1 is found in var1, means this partial string is found in the full string in here, then do a join. What are the problems with this kind of joins? So if you look in here, we have 3 observations in here and 2 observations in here. So in these 3 observations and in these 2 observations, as we are comparing the partial string 80 in these 3 strings, that is in the var1, 80 is there in all the 3 observations, so there is a match. Same is the case with on. you can see that on is there in all the three. Whenever we have this kind of joins where we are matching a partial string with a full string, what happens is there can be a many to many joins. So 80 matches with these three, on matches with these three, and then this gives to many joins. And if you see in here in the results, we see the same. And before going to that, what I want to say is here I am doing select full dot star and partial dot star, means I want all the variables from here and all the variables from here. And the result, you can see that the three observations are matching with 80 and three observations in here are matching with ON. And this leads to a lot of problems, especially if we have lots of records here and lot of matches in here. It will create very large data sets. And another problem is the data becomes very unclear. We do not know what exactly we are trying to match. So we have to be very careful whenever we are joining based off index function or a like operator. I have not given the example of like operator in here, but it works pretty much similar to index function. In this video, we have covered three topics wherein there could be many to many joins, and I have also discussed how to avoid them. That's all for this video. If you like this video, please give it a thumbs up, share and subscribe. Thank you.